I'm just going to continue with doing a bit more practice of this. So to solve this, we need to get rid of this log to unlock that x here and the x here. We could either drop logs or we can convert to an exponent. Here we don't have two logs on both sides of the equation, so we cannot drop logs, so we're going to convert this into the exponent form. Okay, so here's my base, power is 2, my argument is x minus 3. Now that I've gotten rid of logs, it just becomes a quadratic equation. Okay, so solving this, this is not factorable, so this doesn't mean there's no solution, it just means I have to rely on the quadratic formula. So x is equal to 1 plus minus square root of 1 squared minus 4 times a times c, okay, all over 2a. So when we work this out, this has a negative discriminant. Okay, so this cannot be solved, so there's no solution, no real solution anyways. Okay, because of the negative discriminant. Okay, solving this one here, we have to undo all the parts. Okay, so we're gonna undo the plus 1, and so I'm gonna end up with negative 1. I'm gonna undo the times 2, and I'm gonna end up with divide by 2. I'm just gonna put a few steps together because I cannot be efficient by writing every single step down. However, if I don't write enough steps down, I'm going to lose track of things and lose algebraic pieces and make mistakes. So I have to be careful when I'm doing this. Okay, so here I have sine of some angle. This is an angle equals the ratio -1/2. Okay, so this is, I'm going to undo this with arcsine, but remember arcsine has a limited domain, or sorry, limited range, whereas this sine function has many angles that give me the angle, the ratio -1/2. So I'm going to draw this here like this. Okay. Now, because this is a special angle, I don't need a calculator. Okay, I can just use my diagram to undo this equation. So I'm going to end up with the angle 2 pi over 3 times x minus 4 is going to be equal to theta 1 is going to be negative pi over 6. Okay, so that's going to, I'm going to write that as theta 1. I also have 2 pi over 3 x minus 4. That's going to equal to 7 pi over 6. Okay, and that's my theta 2. So those are my main angles, and I just have repetitions of those. Now, to get the repetitions, I really need to know the period of this function. The period of this function, if I look at this, this is already in the period form. The period is 3. So when I do my repetitions, I have to make sure that these repeat with a period of 3. These solutions here repeat with a period of 3. And maybe I'll just highlight these to show that one is from here. Okay, that solution comes from there. And this is a distinct, not a coterminal, but a distinct solution here. There's my theta 1, theta 2 solutions. Okay, so solving for this one here, I just undo all the algebra. I'm going to cancel those